Hello there, and welcome to the Sleepu Thought channel, a place for curious minds to gather, relax, and learn. Tonight's journey is a special one, as we'll venture into one of Earth's most hidden environments. Beneath the waves, far below the reach of sunlight, lies a world few have ever seen. It is vast, it is silent, and it holds secrets stranger than anything we found on land. The deep ocean covers more than half the surface of our planet, yet we've explored only a tiny fraction of it. Entire mountain ranges lie buried beneath the sea, vast trenches plunge miles into the Earth's crust, and all across the seafloor. Creatures drift through darkness, glowing, vanishing, unfurling like alien dreams. Down there light is rare, but life is everywhere. Pressure crushes, but still things move. There are no maps, only mysteries, no footsteps from the echoes. Tonight, we'll journey through that hidden world together, one quiet, astonishing fact at a time. And if you enjoy these gentle journeys, consider liking and subscribing. It helps us reach more sleepy travelers just like you. But for now, let your thoughts float gently as we descend into a realm of blackness, brilliance, and unbroken silence. This is a place where time slows down, where gravity reshapes the earth, and where strange creatures glow and vanish in the dark. Let's begin. Entire mountain ranges are hidden beneath the waves. Beneath the ocean's surface lies one of the longest and least visible mountain ranges on Earth, the mid-ocean ridge. It stretches more than 60,000 kilometers around the globe, sneaking through every ocean basin. These underwater mountains rise from deep rifts where Earth's tectonic plates pull apart, allowing molten rock to well up and cool into new crust. In places, the ridge rises high enough to form islands like Iceland, but most of it remains hidden beneath miles of water. Towering peaks, deep valleys, and volcanic vents make this range one of the most geologically active places on the planet, and yet we've barely mapped it. These submerged mountains influence ocean currents, house entire ecosystems, and shape the planet's crust, all without ever breaking the surface in the deep ocean. Even mountains can go unnoticed, silent and immense. Beneath the rolling waves, the anglerfish hunts with a glowing orb on its head. One of the most haunting predators in the deep is the anglerfish, a creature with razor teeth, a wide, hollow jaw, and a glowing ewer that dangles from its forehead. That glowing orb is a modified spine tipped with bioluminescent bacteria. In the endless blackness of the deep sea, it acts like a beacon, attracting small fish or squid that swim toward what looks like food only to be swallowed whole. The anglerfish doesn't chase prey. It waits in stillness, jaws open light, swaying softly, and when something draws near, it strikes. Females can grow much larger than males and carry the lure. In some species, males fuse permanently, with females becoming little more than living sperm banks. It's a strange, haunting existence. But in a world without sunlight, a single point of light flickering in the dark can mean the difference between survival and starvation. Superheated vents create alien worlds at the bottom of the sea, far beneath the waves, where tectonic plates pull apart and Earth's crust thins, cracks open in the seafloor. From these fishes, superheated water pours out dark mineral, rich and scalding hot. These are hydrothermal vents, and they can reach temperatures over 400 degrees Celsius. Yet even here, in conditions that would destroy most known life ecosystems, flourish. The vents create towering chimneys of black smoke built from dissolved minerals. Around them, life gathers in dense, thriving colonies. Tube worms, giant clams, swarming shrimp. It feels more like science fiction than math, like some deep alien planet lit from below. These vents don't rely on sunlight, but on chemistry. And they remind us that life doesn't need light, warmth, or air, only energy, wherever it's found. In the deepest darkness, where the earth itself breathes, the ocean builds glowing cities of heat and stone. Most of Earth's ocean is wrapped in eternal darkness. If you were to dive beneath the ocean's surface, the light would begin to fade surprisingly quickly. By about 200 meters down, not even a tenth of the way through the ocean's average depth, sunlight disappears almost entirely. Beyond this lies a realm of twilight, then total blackness. The deep ocean is so vast, so profoundly dark, that most of the light on Earth never reaches it. This darkness is not a temporary shadow, but a permanent feature, a kind of planetary night that stretches across millions of square kilometers. And yet, despite this absence of light, the deep is far from lifeless. Creatures here have evolved to see without seeing, to glow in the dark, and to thrive in a world untouched by day. It is a darkness, not of emptiness, but of mystery one. It stretches further than the eye could ever follow. We've mapped more of Mars than our own ocean floor. It may sound unbelievable, but we know more about the surface of another planet than we do about the sea floor beneath our own. Thanks to orbiters and satellites, over 99% of Mars has been mapped in high resolution. The ocean floor, only about a quarter. Much of it remains an indistinct blur, inferred from satellite gravity readings or sonar echoes. We've explored the deep with robots and submarines, but the scale is staggering. Earth's oceans cover over 70% of the surface, and their depths are difficult and expensive to reach. As a result, there are canyons, mountains, and entire ecosystems we've never seen. New species are discovered every time we look. In a way, the deep ocean is our last true frontier, an alien world at the bottom of our own, and it lies just beneath our feet, quietly waiting to be understood. In the deep, pressure can crush a submarine like a can. As you descend into the deep, ocean pressure increases fast and dramatically. Every 10 meters down adds another full atmosphere of pressure, the equivalent of the weight of the entire sky. By the time you reach just a kilometer deep, the pressure is 100 times what we feel at sea level. Go farther and it becomes thousands of times greater. At the deepest trenches, the force is more than 8 tons per square inch, enough to crush steel, collapse submarines, and turn hollow objects into twisted wreckage. But astonishingly, life survives, even thrives under these extremes. Creatures down here are soft-bodied, boneless, and uniquely adapted. Their biology is shaped by compression, their movements slow and ghost-like. For us, this realm is lethal. For them, it's home. The crushing weight of the deep is one of its defining features and one of its greatest mysteries. The ocean's deepest point could swallow Everest with room to spare. The Mariana Trench in the western Pacific Ocean holds the record for the deepest point on Earth. At its lowest measured spot, the Challenger Deep, the ocean plunges to nearly 11,000 meters. If you placed Mount Everest inside it, the peak would still lie more than 2 kilometers below the surface. This trench is not just deep, it's profoundly alien. Temperatures hover near freezing, the pressure is extreme. And yet, even here, life persists. Microbes thrive in the mewed arthropods, and strange fish flit through the dark. And we've only just begun to explore it. Fewer people have visited the Challenger Deep than have walked on the moon. Each descent requires precision engineering and nerves of steel. But with each journey, we learn more about the limits of life, the shape of the planet, and what waits at the bottom of the world. Life flourishes there without a single ray of sunlight. Sunlight is the engine of life on land and in the ocean's upper layers. But in the deep, light never comes. And yet, astonishingly, life continues without photosynthesis. Instead, deep-sea ecosystems run on chemosynthesis, the process where bacteria feed on chemicals like hydrogen sulfide, which bubble up from hydrothermal vents. These bacteria become the base of the food web, nourishing creatures that have never seen the sky. Some animals, like giant tube worms, don't even have mouths or digestive systems. Instead, they host bacteria inside their bodies and absorb energy directly from them. This partnership between microbe and host allows entire ecosystems to bloom in the dark. These strange sunless communities have reshaped our understanding of biology and the possible conditions for life beyond Earth. If life can exist here, it might exist in the deep oceans of other worlds too. Some deep-sea creatures glow like living lanterns in the blackness of the deep ocean. Light becomes a precious resource, and many creatures have evolved to produce their own. This phenomenon is called bioluminescence, and it is astonishingly widespread in the deep sea. Fish, squid, jellyfish, plankton, all capable of emitting light in soft blues, greens, and even rare reds. They do it using chemical reactions inside specialized cells or organs, creating eerie glows that hover in the dark. Some use it to lure prey, others to attract mates. Some flash patterns to confuse predators, or even vanish by, canceling out their own shadows. Bioluminescence is more than beautiful. It's a language of survival for the creatures that live beyond sunlight. Light is both camouflage, signal weapon, and shield. It may be the only thing more common than darkness in the deep, and it turns the midnight ocean into a flickering galaxy of life. Bioluminescence may be the most common light on Earth. Imagine a world where most light isn't from the sun, but from living things in the deep ocean. That's exactly what happens, because the vast majority of Earth's living space lies in the dark, deep sea. The light created by bioluminescent creatures may actually outshine all other natural light sources on the planet. Tiny plankton blink and shimmer as they drift. Fish glow from within. Jellyfish pulse with faint halos. The light is soft, often blue or green, and it travels farther underwater than other colors. This natural glow isn't just beautiful, it's vital. It helps creatures find food, evade predators, and even coordinate movements in the dark. Some fish can flash like lightning, others can keep glowing for minutes on end. On land, we think of light as coming from the sky, but beneath the waves, it comes from the life that hides in the dark. The vampire squid drifts through pitch-black waters like a ghost. Despite its fearsome name, the vampire squid is a gentle creature, slow-moving, delicate, and unlike anything else in the sea. It lives in the oxygen-starved depths of the mesopelagic zone, where few predators dare to follow. Its body is soft and gelatinous, with a cloak-like membrane that stretches between its arms. Inside, it has glowing blue eyes, some of the largest eyes proportionally of any animal on Earth, perfectly tuned to pick up the faintest trace of light. When threatened, it doesn't squirt ink. Instead, it releases a cloud of glowing mucus filled with bioluminescent orbs. These floating sparks confuse predators, buying the squid time to vanish into the dark. It doesn't hunt for fish. Instead, it collects drifting organic particles, marine snow, long filaments, like catching stardust. The vampire squid is not a monster, but a marvel, a living ghost in a world without light. Giant tube worms thrive in water, hotter than boiling. Clustered around hydrothermal vents or superheated water spills into the freezing deep live some of the most unusual animals on Earth. Giant tube worms. They can grow over 2 meters long and live in tubes, made of hardened protein, forming thick red and white forests on the ocean floor. There are no mouths, no digestive tracts. Instead, these worms host colonies of chemosynthetic bacteria inside their bodies. The bacteria feed on toxic chemicals from the vent like hydrogen sulfide and convert them into energy. In return, the worms provide a safe home. This symbiosis allows them to survive in scalding temperatures, crushing pressure, and total darkness. It's an ecosystem built entirely on chemistry, with no need for sunlight. The discovery of tube worms stunned scientists and showed that life could thrive in places previously thought uninhabitable. They may be Earth's most alien creatures living in a world shaped by fire. Some fish can see colors humans never will. In the dark depths of the ocean, color might seem useless. After all, most visible light never reaches beyond a few hundred meters. But some deep sea fish have evolved eyes that can detect parts of the light spectrum we can't see, including near-infrared and certain shades of red or ultraviolet. These special adaptations allow them to spot prey that tries to hide using camouflage, or even communicate using subtle flashes invisible to other predators. The brown snout spookfish, for example, has a mirror-like structure in its eye that helps it detect faint glimmers of light from below. Other species have multiple visual pigments tuned to different wavelengths, giving them an almost alien kind of vision, where we would see only blackness. These fish can detect flickers and shadows, hints of movement, signs of life in the ocean's eternal night. Their eyes become their secret advantage. Other creatures are nearly invisible, and that's on purpose. In a place with no shelter, no rocks or coral, to hide behind, the best defense is to vanish completely. Many deep-sea creatures have evolved bodies that are almost perfectly transparent. Their skin muscles and even some internal organs are made of jelly-like material that barely bends or reflects light. The result is a near-invisible body that predators can't easily detect. Some fishes are transparent. You can see their skeletons. Others, like the glass squid, are nearly invisible, except for their eyes, which they disguise using mirrors or special pigments. Even their blood lacks pigment to reduce visibility in the deep ocean. Visibility isn't just about hiding from predators. It's about survival at every level. To float unseen through a world without shadows is a powerful adaptation. In the quiet, dark, transparency becomes a form of armor. Elegant, ghostly, and nearly perfect. The gulper eel can open its mouth wider than its own body. The Gauta eel is one of the deep sea's most surreal residents, a shadowy creature with a whip-like tail and a ballooning jaw. Its mouth is so massive it can open wider than the eel's entire body, forming a kind of living fishing net. Despite its fearsome appearance, the gulper eel is not a fast hunter. Instead, it drifts through the blackness, waiting for small fish or shrimp to swim by. Then, with one sudden motion, it opens its enormous mouth and gulps. Its body can stretch to hold surprisingly large meals, making it a master of rare opportunities in a world where food is scarce. It also has a bioluminescent lure at the tip of its tail, a glowing dot that it can wave to attract prey. In the still black waters of the abyss, the gulper eel is part monster, part illusion, and entirely real. Every night, deep creatures rise toward the moonlight. When the sun sets and the ocean surface grows dark, something extraordinary happens in the deep. Millions of creatures, fish, squid, jellyfish, and plankton begin to rise. Slowly, silently, they migrate upward from the twilight zone to feed in the nutrient-rich upper layers. It's called the dual vertical migration, and it's the largest movement of animals on Earth. This nightly journey happens across the globe, from the tropics to the poles, and repeats. Every 24 hours, like a planetary heartbeat, the creatures rise to feed under cover of darkness, then retreat again before dawn to avoid predators. It's a delicate dance between hunger and safety, light and shadow. Most of it is invisible to us, hidden beneath waves and moonlight. But this migration shapes ecosystems, affects carbon cycles, and keeps the deep connected to the surface in the ocean's rhythm. Night is the time to rise. This nightly migration is the largest on the planet. Each evening, trillions of marine animals ascend from the deep, not just a few meters, but sometimes up to a kilometer or more. The sheer scale is staggering. Imagine every living human being rising and falling in perfect synchrony every night. Now multiply that by 1,000. This vertical migration moves more biomass, more total living matter than any other daily movement on Earth. It helps regulate the planet's climate by transferring carbon from the surface into the deep ocean, where it can remain for centuries. And it does all this in near total silence, far from human eyes. Creatures like lanternfish, hatchetfish, and tiny crustaceans make this track under the cover of darkness, guided by cues we barely understand. Perhaps temperature shifts or the faint rise of moonlight. It's one of the most important processes on the planet, and we're only beginning to understand how it works. Sound travels faster in the deep than in the air. In the ocean, sound behaves very differently than it does in the air. Water is denser and more elastic, which means sound waves move through it much faster, about 4 times faster. In fact, the deeper you go, the faster the sound travels. At the surface, sound might move at around 1/500 meters per second, but in the crushing pressures of the deep, it can be even faster. This speed allows whales to call across vast distances, sometimes hundreds of kilometers. And it's not just faster. Sound also travels farther underwater than light or smell. That's why so many deep-sea creatures rely on sound to communicate, navigate, and hunt. In a world without light, hearing becomes one of the only ways to sense the environment. The ocean is often described as silent, but in truth, it's full of sound. We just haven't always known how to listen. The ocean has a hidden layer that traps sound like a whispering cave. Deep beneath the surface lies a strange acoustic phenomenon called the Safa channel, short for sound fixing and ranging. It's a horizontal layer of water where the speed of sound is at its lowest, due to a perfect balance between temperature and pressure. Sound waves entering this layer don't scatter in all directions. They get bent back inward, trapped and funneled horizontally across vast distances. A single low-frequency sound can travel for thousands of kilometers inside the Safa channel, barely losing energy. Submarines use it, so do whales. And in the 1960s, scientists even placed underwater microphones here to monitor for distant nuclear tests. It's like a natural whispering gallery that encircles the globe, a place where voices can travel far beyond the horizon. In the deep sea, this hidden sound tunnel connects worlds that are otherwise lost in darkness and silence. We've recorded bizarre noises in the deep we can't explain ever since humans began listening to the ocean with underwater microphones called hydrophones, with picked up sounds that defy explanation. Some are low rumbles, others are short bursts or eerie moans. Many don't match the patterns of any known marine creature, seismic event, or man-made noise. Scientists have cataloged these unexplained sounds, often giving them whimsical names like Upsweep, Slowdown, and Julia. Some are seasonal, some only happen once. Their origins remain mysterious. Are they caused by shifting icebergs deep under sea quakes? Massive animals we've never seen we don't yet know? These sounds remind us how much of the ocean remains uncharted, not just visually, but acoustically. The deep sea isn't silent. It speaks in voices we can record, but not always understand. Listening to these unknown echoes is like overhearing a conversation in a language we haven't learned yet. One strange underwater sound was dubbed the bloop. In 1997, a strange and powerful sound was detected by underwater microphones in the South Pacific. It was low, deep, and loud, so loud, in fact, that it was picked up by sensors over 5,000 kilometers apart. Scientists called it the bloop. At first, it baffled researchers. The sound had characteristics similar to those of an animal core, but no known creature could produce a sound so powerful. Was it a whale? A seismic event? Something unknown? Speculation ranged from deep-sea monsters to undiscovered leviathans. Eventually, the best theory pointed to the cracking and collapse of massive Antarctic icebergs. But for years, the bloop captured the imagination of oceanographers and science enthusiasts alike. It reminded us that the ocean can still surprise us, that sometimes a single unexplained sound can echo through both water and wonder, stirring the imagination as much as the ear. Some fish communicate by drumming on their own bodies. While whales sing and dolphins click, some fish have evolved much stranger ways to communicate. They drum using special muscles attached to their swim bladders, the internal sacs that help control buoyancy. These fish can create rhythmic thumps, pulses, or grunts. It's a bit like beating a drum from the inside out. These sounds can serve many purposes, attracting mates, defending territory, or signaling distress. The toadfish, for example, makes a humming call so loud it can be heard through the hulls of boats. Other fish use short bursts to coordinate with a group or ward off intruders. In the dark, noisy world of the ocean, sound becomes a private language, one that's often overlooked by human observers. These simple drumming rhythms are reminders that even the quietest fish may have a voice if only we know how to listen for it. Whales dive for miles to sing when no light reaches. Among the deepest divers in the animal kingdom are whales, especially species like the sperm whale and the Cuvier's beaked whale, which can dive over 3 kilometers beneath the surface. They go there to hunt, to hide, and in some cases to sing. Whale song is one of the most haunting and beautiful sounds in nature. Long, echoing calls that can travel for thousands of kilometers. Some whales dive deep before they begin singing, where ambient noise is lower and the sound can carry farther. These songs may serve many functions, attracting mates, locating others, or mapping the sea using echoes. They're so complex that they may even contain dialects or patterns that change over time. In the dark silence of the abyss, a single whale's voice can fill the water like music in a cathedral. It is sound without light, language without land. Giant squid, or once sea monsters, until we filmed them alive. For centuries, giant squid were the stuff of sailors. Nightmares glimpsed in fragments, washed ashore in pieces, or tangled in fishing nets. They were called kraken leviathans, monsters of the deep. No one had seen one alive in its natural habitat until 2012, when Japanese researchers captured the first video of a living giant squid filmed over 600 meters below the surface. What they saw was dazzling, a sleek, graceful creature with shimmering skin and eyes the size of basketballs. Its arms moved like ribbon silk, trailing hundreds of tiny suction cups. It wasn't a monster, it was a mystery made real. The deep sea still holds many secrets, but the giant squid is no longer just a legend. We've seen it, and that glimpse confirmed what mariners had whispered for centuries, that something enormous waits in the dark. Now we know they have tentacles longer than a bus. A fully grown giant squid can reach lengths of up to 13 meters more than the length of a city bus. Most of that size comes from two incredibly long feeding tentacles, which are tipped with suckers lined with tiny serrated rings. These tentacles can shoot out to snatch prey with astonishing speed, drawing fish and other squid back toward a hooked beak hidden at the center of the arms. The giant squid's body is soft and boneless, allowing it to survive at extreme depths and squeeze through narrow gaps. But its size and power are undeniable, especially when you realize that it may not even be the largest squid in the sea. The colossal squid, its close cousin, might be even heavier. Deep in the darkness, unseen battles between giants could still be taking place. Tentacle against tooth, myth against mystery, the colossal squid has eyes the size of dinner plates. Of all the creatures that inhabit the deep ocean, none has eyes quite like the colossal squid. Each eye can reach 25 centimeters in diameter, about the size of a large dinner plate. They are the largest eyes known in the animal kingdom, evolved to gather the faintest glimmers of light in the abyss. With such eyes, the squid can detect distant bioluminescent flashes, the ghostly flicker of prey, or the approach of a predator. These massive creatures are rarely seen, but when they are, they leave a powerful impression. One specimen captured near Antarctica had sharp swiveling hooks on its arms and weighed over 500 kilograms. The colossal squid is bulkier and more powerfully built than its giant cousin, and it may still be growing in the frozen dark of the Southern Ocean. This nearly mythic beast drifts enormous and unseen. Some deep creatures keep growing their entire lives. On land, most animals stop growing once they reach adulthood. In the deep ocean, it's not always so simple. Many species, including some fish, crustaceans, and cephalopods, continue growing throughout their lives, slowly adding mass and size over the years. This phenomenon, known as indeterminate growth, may help these creatures adapt to the harsh conditions of the deep, low temperatures, scarce food, and immense pressure. It also means that given enough time, some deep-sea animals can reach enormous sizes. Slow metabolism and long lifespans allow for gradual, almost glacial growth. In this still cold world, nothing needs to hurry. Over decades or even centuries, a small creature might become a giant, and we may have only seen the younger ones somewhere in the darkness. The elders of the deep may still be growing unseen and unmeasured, older than memory. The frilled shark looks like a fossil, come to life, sometimes called a living fossil. The frilled shark is one of the most ancient-looking creatures in the ocean. It has a long eel-like body, a wide mouth full of needle-like teeth, and gill slits that form frilly collar-like fringes along its throat. It rarely ventures near the surface, spending most of its life in the cold, dark depths between 500 and 1,000 meters below. Its lineage dates back over 80 million years, and its body has changed very little since then. It moves in slow serpentine motions, striking quickly when prey comes near. Few people have ever seen one alive. Most encounters come from deep trolling nets or remote cameras, but every glimpse reminds us that the ocean holds creatures shaped by ancient worlds, animals that seem to have drifted forward through time, carrying echoes of the distant past. Rivers and lakes exist at the bottom of the sea. It sounds impossible, but it's true. Under the sea, there are rivers and lakes, bodies of water within water. These strange features form when dense, salty brine gathers in depressions on the seafloor. Because the brine is heavier than the surrounding seawater, it doesn't mix easily. Instead, it forms shimmering, slow-moving pools with visible shorelines, currents, and even waterfalls. Some are surrounded by mussels and tube forms. Others are eerily still with toxic chemistry that few organisms can survive. Divers and submarines that approach often report a surreal sight, the sensation of flying over a separate sea. These lakes can be tens of meters deep and hundreds wide, complete with waves and ripples. It's a layered world within a world, like a secret ocean hiding inside another in the deepest reaches of Earth. Water doesn't always behave the way we expect. Some undersea pools are so salty that toxic. At certain depths, the ocean hides something astonishing. Brine pools by salt concentrations are so high that the water becomes heavier than the sea around it. These pools can be several times saltier than normal seawater, forming dense lakes on the seafloor that don't mix with the ocean above. The chemistry inside is often lethal to most marine life, lacking oxygen, laced with hydrogen sulfide, and nearly still. Some creatures have adapted to live at the pool's edges, but any fish that wanders too far inside may never come out. Submersibles that explore these pools describe eerie underwater shorelines, complete with rippling surfaces and even waterfalls. The sight of a lake beneath the sea, complete with its own tides and shores, is one of the most surreal discoveries in oceanography. These toxic pools are quiet reminders that the deep doesn't always follow the rules of water. The seafloor isn't flat. It's full of sunken valleys and towering cliffs. When we imagine the bottom of the ocean, it's easy to picture a vast, featureless plain. But in reality, the seafloor is just as rugged and dramatic as any mountain range on land, and sometimes even more so. Deep beneath the waves lies steep escarpments, massive undersea cliffs, sprawling trenches, and volcanic ridges. Some cliffs drop 4 kilometers in near vertical walls shaped by shifting tectonic plates or ancient landslides. Others form the boundaries of underwater plateaus and fracture zones. Because of the difficulty of mapping the deep, many of these features remained hidden for decades, and some are still being discovered. Just like the continents, the ocean floor is scarred and sculpted by geologic time. Every valley is a record of collapse or creation, every reach a frozen moment of fire. Even when no sunlight ever reaches the Earth's forces are still at work. Abyssal plains stretch across the ocean like endless deserts, far below the surface. Between 3 and 6 kilometers deep lie the abyssal plains, vast flat expanses that cover more than half of the ocean floor. These plains are some of the flattest regions on Earth, formed by the slow settling of sediments over millions of years. But while they may seem barren, they are not lifeless. Tiny organisms burrow in the mud, scavengers patrol the darkness, occasional whale falls create oases of life. To visit an abyssal plain is to enter a place where time moves slowly, where silence is absolute, and where each particle of marine snow, organic matter drifting down from above, is a treasure. These plains are both alien and familiar, wide still and strangely peaceful. They're the true seabed of the world, stretching beyond the limits of light or sight. They are the ocean's quiet, a moving heart. The Mariana Trench is Earth's deepest scar. The Mariana Trench, located in the Western Pacific, holds the record for the deepest part of Earth's oceans and of the planet's crust. It plunges nearly 11,000 meters below sea level at its lowest point, known as the Challenger. Deep that's deeper than Mount Everest is tall. The trench is not a crack or a canyon, but a vast curving depression formed by immense geological forces. It's the result of one tectonic plate sliding beneath another in a process called subduction. The result is a kind of scar, a slow grinding wound in the Earth's surface that has been growing for tens of millions of years. Down there, the water is near freezing, the pressure is crushing, and light never reaches. Yet even in this most extreme environment, life finds a way. The Mariana Trench reminds us how deep the Earth truly goes and how far mystery can stretch. Trenches form where continents sink into the mantle. Oceanic trenches are some of the deepest and most dramatic features on the planet, and they are created by one of the most powerful processes in geology, subduction. Along certain boundaries, tectonic plates collide and the denser oceanic crust is forced downward beneath lighter continental crust. As it sinks, it drags material deep into Earth's mantle, forming a deep trench of the boundary line. These trenches can be thousands of kilometers long and several kilometers deep. They are zones of earthquakes, volcanoes, and intense pressure, but they are also ancient, marking the slow recycling of Earth's surface over tens of millions of years. The Pacific Ocean is ringed by these deep scars, forming what's known as the Ring of Fire. From above, they are invisible, but far below, they are the grinding edges of continents, places where the crust folds, cracks, and disappears into the deep. Even the deepest trenches hosts strange living creatures the year. Scientists believe that nothing could survive in the crushing darkness of the ocean's deepest trenches, but they were wrong. With the help of deep-diving submersibles and robotic landers, we've discovered that even the Challenger Deep, nearly 11 kilometers down, is home to life. Amphipods scuttle through the mud. Microbes live in the sediment. Strange, translucent fish with fragile fins and ghostly bodies drift slowly near the bottom. These creatures survive in freezing temperatures, with no sunlight and under pressures over 1,000 times that of the surface. They've adapted in ways we're still trying to understand, with flexible membranes, pressure-resistant enzymes, and unique metabolic tricks. Even at the very limits of the biosphere, life refuses to yield. The deepest trenches are not lifeless voids. They are hidden worlds, fragile, quiet, and still very much alive. Some fish thrive in waters with almost no oxygen. In many parts of the deep ocean, oxygen levels are so low they would suffocate most known animals. These oxygen minimum zones exist at depths between 200 and 1,000 meters, places where the oxygen minimum zones exist at depths between 200 and 1,000 meters. Water is too far from the surface to be refreshed by the wind and too deep for photosynthesis. But life still finds a way. Some species of fish, like the slender fangtooth or certain types of lanternfish, have evolved to survive with barely any oxygen at all. They slow their metabolisms, reduce muscle activity, and rely on specialized proteins that help them extract the tiniest traces of oxygen from the water. Others may use gills with massive surface areas or shift their behavior to avoid the worst conditions. These fish don't just survive where others would die, they thrive in the quiet oxygen starve. Deep resilience is everything. Others feed on nothing but falling dust. Many deep-sea creatures don't hunt, chase, or bite. Instead, they wait. They feed not on other animals, but on tiny particles drifting down from the upper ocean, a slow, steady rain of organic matter known as marine snow. These particles are the remains of dead plankton, tiny fecal pellets, discarded exoskeletons, and other microscopic debris. Though each flake is nearly weightless, together they form the primary food source for vast regions of the seafloor. Sea cucumbers, brittle stars, crabs, and deep-dwelling worms sift through this sediment like scavengers in a cosmic snowfall. In some regions, entire ecosystems are sustained by this delicate stream of nutrients. Life here moves slowly, conserving energy, making the most of every particle in the deep. There are no fast meals, only patience, and the knowledge that even the smallest speck can be a feast. Marine snow drifts down like an eternal ghostly blizzard. Imagine a snowfall that never melts, not of ice, but of organic dust. In the deep sea, marine snow is a constant slow-motion blizzard. Tiny flakes of dead plankton, algae, fish, scales, mucus, and microscopic waste drift endlessly downward from the sunlit surface. Most flakes are barely visible. Some clump together, forming delicate webs or pellets. They can take weeks or even months to reach the dolphin. But for deep-sea creatures, marine snow is life. It delivers nutrients to places where nothing grows, linking the surface world to the abyss in a kind of invisible food chain. Some animals filter it from the water. As it falls, others graze the sea floor, collecting what settles there. It may seem unremarkable, but this soft, silty snowfall is one of the most important biological processes on Earth, connecting life across layers of depth and time. A whale fall feeds life for decades in the deep. When a whale dies and its body sinks to the bottom of the ocean, something extraordinary happens. That carcass, sometimes weighing over 30 tons, becomes a vast temporary ecosystem known as a whale fall. For decades, layer by layer, life moves in. First come scavengers, sharks, hagfish, and giant arthropods that strip away the flesh. Then other creatures move in to feast on scraps and soft tissue. As time passes, the bones themselves become food. Bacteria that feed on fats within the bones release chemicals like hydrogen sulfide, attracting chemosynthetic worms and mollusks, the same kinds of life seen at hydrothermal vents. A single whale fall can support over 100 species of animals, many of which are found nowhere else. In the dark, where food is rare, a whale's body becomes a gift, a slow-burning feast that echoes through the ecosystem for years. Some creatures eat bones and nothing else. Deep in the ocean, where meat is scarce and survival is hard, a few creatures have evolved to do the unthinkable. They eat bones. The most famous of these is the ostax worm, also known as the bone-eating zombie worm. It has no mouth, no stomach, and no eyes. Instead, drills into the bones of fallen whales, using acid, and absorbs the nutrients inside. To do this, it relies on symbiotic bacteria that help it digest fats and collagen. These worms grow root-like tendrils that anchor into the bone, while feathery plumes extend from their bodies to extract oxygen from the water. They are delicate, ghostly, and oddly beautiful, a perfect example of life adapted to extremes. In a world where food arrives once in a generation, nothing is wasted. Even bones become a banquet, even decay becomes life. The deep holds more living mass than any other place on Earth. It may seem hard to believe that the deep ocean is home to the largest concentration of life by biomass on the planet. Though individual animals may be small or rarely seen, their sheer numbers are staggering. Tiny creatures like copepods, krill, and jellyfish form thick clouds that stretch for miles. Enormous schools of lanternfish, estimated in the trillions, migrate up and down each day in the planet's greatest hidden journey. These creatures feed larger predators, recycle nutrients, and form the foundation of marine food webs. Together, they outweigh the total mass of all land animals combined. The deep is not barren. It's busy, intricate, and absolutely full. But because so much of that life is out of sight, we've only begun to measure it. Beneath the silence, the deep ocean is pulsing with life more than we ever imagined. Even in the dark, life in the deep is incredibly diverse. At first glance, the deep ocean might seem like a lonely place, silent, vast, and sparsely inhabited, but that impression fades the deeper we look. In truth, the deep sea may be one of the most biodiverse habitats on Earth. Every expedition into the abyss reveals new species. Glowing fish, feathery worms, jelly-like mollusks, delicate crustaceans, many are found nowhere else. Some live in the mud, others cling to vents or coral, and still more drift freely in the water, even within a single square meter of seafloor. Scientists have counted hundreds of distinct organisms, and most of them are tiny, almost invisible to the eye. The deep rewards specialization, and creatures here have evolved in strange, isolated ways. In total darkness, diversity doesn't fade. It flourishes. Life in the deep isn't rare. It's just quiet, hidden, and exquisitely tuned to the silence. Some ocean creatures can live for over 200 years down in the cold, dark waters of the deep. Time seems to stretch. Many animals here grow slowly, age gradually, and live far longer than their surface-dwelling relatives. Some species of deep-sea clams and tube worms are known to live for more than 2 centuries. Others, like certain cold-water corals, can survive for over 4,000 years, quietly building reefs that outlast civilizations. These extreme lifespans are possible because of low temperatures, slow metabolisms, and minimal environmental stress. With fewer predators, less competition, and little need to rush, deep-sea creatures often take their time growing patiently across decades, sometimes centuries. To us, it's nearly unimaginable, but in the deep, longevity is a way of life. Each ancient clam or coral is a living archive, a survivor of 1,000 storms, a witness to ages we've already forgotten. The Greenland shark may be 500 years old. The Greenland shark is one of the ocean's most mysterious giants, a slow, moving predator that drifts through the icy depths of the North Atlantic. For years, its age was unknown. Then in 2016, researchers made a startling discovery. Using radiocarbon dating of proteins in the shark's islanders, they estimated one individual to be nearly 400 years old, possibly more. Some may live to 500. That would make the Greenland shark the longest living vertebrate on Earth. These sharks grow slowly, just a few centimeters per year, and don't even reach maturity until they're around a century old. They swim in deep, frigid waters, where time moves differently, where cold and pressure stretch life across the centuries. No one has ever seen one give birth. No one knows exactly how old they can get. In the deep, age isn't counted in years, but in quiet endurance. Cold and darkness slow down time for living things. Life in the deep ocean moves at a different pace. Temperatures often hover just above freezing, and light never penetrates past a certain depth. These conditions change everything, especially time. Pool temperatures slow metabolic rates, allowing animals to conserve energy and reduce wear on their cells. Many deep-sea creatures grow slowly, reproduce rarely, and live for decades, or even centuries. A single meal might last for weeks. A generation might stretch across half a century in the absence of light and warmth. Evolution favors stillness, patience, and endurance. What feels like a moment on the surface might be a year in the deep. This slowness is not a weakness, it's a strategy. In a world where food is rare and change is gradual, living slowly means living well in the deep. Time flows like the cold water, vast, gentle, and unhurried. Some fish survive by producing their own antifreeze in the coldest parts of the ocean, where temperatures dip below freezing. Many fish would freeze solid without special adaptations, but some have evolved a clever solution: anti-freeze proteins. These proteins circulate in their blood and tissues, binding to ice crystals and preventing them from growing. It's the same basic principle as the antifreeze in a car, but far more elegant. These antifreeze-producing fish are found in polar oceans and deep, frigid waters. Their bodies remain soft and flexible, even in the cold, allowing them to move, feed, and survive in environments that would otherwise be fatal. Scientists have even studied these proteins to improve cryopreservation techniques on land. It's a reminder that extreme cold isn't always a barrier in nature. It's a challenge, and evolution laughs. A challenge where ice would stop most hearts. These fish keep swimming. Others are so soft they'd collapse if brought to the surface. Some deep-sea creatures are made almost entirely of gelatinous material, soft, delicate, and nearly formless at great depths. This softness is an advantage. Without a rigid skeleton, they can resist the crushing pressure simply by being flexible. But if they were suddenly brought to the surface, they collapse not from injury, but because their bodies depend on high pressure to maintain shape. The famous blobfish, for example, looks like a sidey cartoon on land, but at its natural depth, it's sleek and well-formed. Other creatures, like certain jellies or comb jellies, would disintegrate almost instantly in normal air pressure. These animals have evolved for one specific environment, the deep. Their beauty is fragile, their survival is precise, and their bodies are shaped by forces most of us will never feel: the invisible weight of miles of water pressing in from all sides. Some deep creatures have no bones at all. In the crushing pressure of the deep ocean, softness becomes a form of strength. Many creatures here have no bones, no rigid skeletons or hard shells. Instead, they're made of soft tissues, cartilage or gelatinous material that can bend and flex with the water around them. This makes them incredibly pressure tolerant. While the bony body might crack or collapse, these creatures simply compress and expand as needed. Some look like drifting ghosts. Others resemble ribbons, umbrellas, or glass sculptures. Their softness isn't a flaw, it's an exquisite adaptation. Even fish that do have skeletons often have lightweight, flexible bones or reduced structures that give them more mobility and less fragility in the deep. Structure is secondary. Survival means yielding to the environment, moving with the currents, and staying quiet in the dark. These soft-bodied wonders remind us that vulnerability can also be resilience. Entire ecosystems exist with no sunlight ever. Most of life on Earth depends on sunlight. Plants capture it, animals eat the plants, and the cycle continues. But deep in the ocean, far beyond the reach of even the faintest ray, entire ecosystems exist in complete and permanent darkness. These aren't just a few stray species around hydrothermal vents and cold seeps. Scientists have found dense communities of life, tube worms, shrimp, crabs, mussels, and strange fish. There are no photosynthetic plants, only organisms that live by chemosynthesis, using chemical energy instead of light. These ecosystems don't depend on the surface at all. They form their own closed world, powered by the heat and elements leaking from inside the Earth. When these environments were first discovered in the 1970s, they upended our understanding of what life needs, and they offered a possibility even more profound, that life might not need sunlight at all. Instead of photosynthesis, life down that runs on chemistry, sunlight fuels almost every food chain on the planet, except in the deep ocean. Here's something remarkable happens. Life runs on chemistry around hydrothermal vents and methane seeps. Microbes use the energy stored in chemicals like hydrogen sulfide, methane, and iron to create organic matter. This process, called chemosynthesis, allows life to flourish without the sun. It's similar to photosynthesis, but instead of light, it uses molecules from the Earth itself. These chemosynthetic microbes form the base of entire ecosystems, feeding tube worms, clams, and crustaceans that gather in dense colonies around vents. It's a different kind of energy, ancient, elemental, and invisible, and it may be one of the earliest forms of life on Earth. Some scientists even believe chemosynthesis could support life on other planets or moons. In the deep sea, chemistry becomes cuisine and life rewrites the rules of survival. Microbes feed on sulfur that leaks from Earth's crust at hydrothermal vents. The water gushing out isn't just hot, it's full of dissolved minerals, including toxic chemicals like hydrogen sulfide. This gas would be deadly to most surface life, but in the deep, certain microbes have evolved to feed on it. These sulfur-loving bacteria form dense mats on rocks, coat vent chimneys, and even live inside the tissues of larger animals. They use the energy from the sulfur to fuel chemosynthesis, creating sugars and organic molecules that support other life. Some tube worms have no mouth or digestive systems at all. Instead, they house these microbes within their bodies and absorb the nutrients they produce. It's a remarkable partnership: sulfur from the Earth, microbes from the deep, animals from the dark. Together, they form ecosystems as rich and complex as any coral reef without ever needing light. These tiny organisms power entire deep-sea food webs in the deep where no light penetrates. The smallest creatures often carry the greatest weight. Chemosynthetic microbes, though invisible to the naked eye, form the base of deep-sea food chains around vents and cold seeps. They transform toxic chemicals into energy, producing organic matter that feeds shrimp, crabs, mollusks, and other vent dwellers. These in turn feed larger predators like deep-dwelling fish or octopuses. Every life form in this system ultimately depends on the microbes, even if they never interact directly. It's a web that doesn't begin with sunlight, but with sulfur, methane, and iron. Without these microscopic powerhouses, the vent communities would collapse. The role is quiet, constant, and vital. And because chemosynthesis might predate photosynthesis, these microbes may represent one of life's oldest strategies, a kind of living memory from the earliest oceans. In their simplicity lies the key to an entire hidden world. Cold water corals build vast cities in the dark. Coral reefs aren't just tropical. In the freezing depths of the ocean, far from sunlight, cold water corals quietly build vast complex structures that rival their shallow water cousins. These corals don't rely on photosynthesis. Instead, they catch tiny particles of food, drifting through the current using delicate feathery arms. Over thousands of years, they grew into massive reefs, some stretching 4 kilometers. These reefs provide shelter for countless deep-sea species fish forms, crustaceans, and sponges. There are hotspots of biodiversity in an otherwise sparse world. Many cold water corals grow slowly, just a few millimeters per year, but given enough time, they can form underwater cities teeming with life. These reefs are hard to reach and only recently mapped by sonar and submersible expeditions. Some have already been damaged by trawling or climate change, but even in the darkness, they continue to grow delicate fortresses, sculpted by time. Some coral reefs are older than human civilization. In the deep ocean, coral grows slowly, sometimes just a few millimeters per year, but given enough time, that slow growth becomes something monumental. Some cold water coral reefs are estimated to be more than 8,000 years old, meaning they began forming before the first cities were built on land. These reefs are hidden in darkness, built by creatures that never see the sun. And yet, over centuries, they form towering mounds and sprawling habitats that shelter entire ecosystems. Each new coral polyp builds on the skeletons of those that came before, layer upon layer, across millennia. While shallow reefs often come and go, with the tides of warming oceans, some deep reefs have endured ice ages and survived the shifting of continents. These aren't just reefs, they're living archives, built slowly in silence, telling stories that long predate our own. Deep water corals grow without ever seeing the sun. Unlike the bright corals of tropical shallows, deep water corals have no need for sunlight. They don't rely on algae for food as their surface-dwelling cousins do. Instead, they capture small bits of drifting organic matter from the water. Around them, tiny particles of marine snow, bits of dead plankton, and microscopic life. These corals grow in cold, dark water, sometimes more than 1,000 meters deep. Their shapes vary wildly: spirals, fans, branches, and curls. Some glow faintly under special lighting, revealing colors hidden from natural view. Though they live far from human eyes, they are vital to deep-sea biodiversity, forming reef structures that act as shelters, nurseries, and hunting grounds. Their beauty is subtle, often seen only through the lens of a remote camera, but it's their intricate, delicate, and undiminished by darkness. New coral reefs are still being found today. With all our technology, it might seem like we've already discovered most of what Earth has to offer, but in the deep ocean, surprises still wait. In recent years, scientists have discovered entirely new coral reefs, some stretching 4 kilometers, others hidden beneath submarine cliffs or along continental slopes. One reef off the coast of South Carolina was over 130 kilometers long and previously unknown. These discoveries often happen by accident: a sonar scan, a passing submersible, or a curious blip on a map. The deep is vast and largely unexplored, so it's likely that many reefs and the life they support remain unseen. With each new reef comes new questions. How old is it? What species live there? How can it be protected? Even now, the ocean continues to surprise us, and every new reef is a quiet reminder that Earth still holds secrets. We use robots to explore where no human can swim. The deep ocean is a place of extremes: freezing temperatures, intense pressure, and absolute darkness. It's no place for unprotected to humans. So instead, we send robots. These machines, called ROVs, remotely operated vehicles, are equipped with cameras, lights, robotic arms, and sensors piloted from ships of the surface. They can dive for hours or even days, transmitting real-time video and data from miles below. Some can hover above vents. Others collect samples, measure temperature, or map terrain with sonar. They've been used to discover new species, study deep-sea ecosystems, and even locate shipwrecks lost for centuries. The footage they return is often breathtaking: glowing jellies, towering coral, volcanic landscapes. These robots don't just extend our reach, they extend our imagination in a world we cannot visit ourselves. They go in our place eyes in the dark explorers of the unseen. Some drones dive for hours beaming back glimpses of the unknown. Many of today's deep-sea drones are autonomous, meaning they don't need constant human control. These UVS autonomous underwater vehicles follow programmed paths gliding through the ocean in search of data. Some map the seafloor in high resolution. Others measure temperature, salinity, or chemical signatures in the water. Equipped with cameras, lights, and senses, they can drift through the abyss for hours, even days, sending their findings back via satellite. When they return, these drones can explore tight spaces, follow currents, and enter regions that would be too risky for human divers or tethered robots. They found hydrothermal vents, coral gardens, and entire ecosystems we didn't know existed. And with every mission, they teach us something new. In the deep, where even light cannot go, machines carry our curiosity, quietly charting a world we've only just begun to understand. A few submarines can carry humans to the ocean's abyss. While most deep-sea exploration is done by robot, a few specialized submersibles are built to carry human passengers all the way down. These vessels are shaped like reinforced spheres, able to withstand crushing pressures many kilometers below the surface. Inside, explorers sit shoulder to shoulder in cramped darkness, peering through tiny windows or watching live feeds from cameras. Outside, the experience is quiet, surreal, and otherworldly, a slow descent into cold silence. Only a handful of humans have ever visited the Challenger Deep, the deepest known point in Earth's oceans. Most descents last several hours, with only minutes spent on the seafloor. But what's seen there leaves a lasting mark. Alien landscapes, strange creatures, and the inescapable sense of isolation. These manned dives are rare and dangerous, but also deeply human. In a world mostly beyond our reach, sometimes we still choose to go in person. In 1962, people reached the deepest part of the ocean. On January 23, 1960, oceanographer Jacques Piccard and U.S. Navy Lieutenant Don Walsh descended into the Challenger Deep, the deepest known part of the world's oceans. Their vehicle was the Triasta Deep Diving Research Bather Scarf, built like a reinforced steel balloon. It took them nearly 5 hours to reach the bottom, over 10,000 meters below the surface. Down there, they found total darkness, crushing pressure, and surprisingly signs of life. Though their visibility was limited, they reported seeing flatfish and shrimp-like creatures. They stayed on the seafloor for just 20 minutes before beginning the long journey back up. No one had ever gone that deep before, and no one would again for more than 50 years. The quiet dive into the deepest part of Earth marked a turning point in human exploration, a moment when courage met the unknowable and didn't turn back. The vessel was called the Trieste, and it survived the crushing dark. The Trieste was unlike any other submarine ever built. Its most important feature was its precious sphere, a fixed steel capsule just large enough to hold 2 people suspended beneath a massive tank filled with gasoline. For buoyancy at the bottom of the ocean, the pressure exceeds 8 tons per square inch, enough to crush most submarines like paper. But the tree has held firm. Its descent was slow, its windows tiny, and its interior claustrophobic. The walls groaned, a viewing panel cracked from the pressure. But it didn't fail. When Piccard and Walsh reached the bottom, they stirred up so much sediment that they couldn't see outside, only the faint glow of their lights swallowed by swirling darkness. Still, they had made it. The Trieste proved that humans could go deeper than ever imagined, and for a long time, it remained the only vessel to do so. Fewer people have visited the Challenger Deep than the Moon. As of today, fewer than 20 people have ever visited the Challenger Deep, the deepest known point in Earth's oceans. In contrast, 12 astronauts walked on the Moon during the Apollo missions. The Challenger Deep is more remote, more hostile, and harder to reach than outer space. In many ways, the crushing pressure, total darkness, and extreme isolation make each descent a monumental engineering and psychological challenge. For decades after the Trieste's dive, no one returned. Then in 2012, filmmaker James Cameron completed a solo dive to the bottom, becoming the first person to go alone. In the years since, a handful of other missions have followed, each revealing something new. But still, it remains one of the least visited places on Earth, a pit in the planet so deep, so silent, that most of it is still untouched, a kind of underwater lunar surface. Today's explorers use cameras, lights, and robotic arms. Modern deep-sea exploration blends technology and precision. While manned dives still occur, most research today is carried out by remotely operated vehicles. ROV robotic explorers equipped with high-definition cameras, bright LED lights, and multi-jointed arms that can collect samples, place instruments, or even pick up fragile creatures without harming them. These machines are guided by pilots aboard research vessels on the surface, sending back live video feeds from depths of thousands of meters. Some ROVs are built for mapping, others are designed for science, and all are made to survive the extremes of the deep pressure, cold, and total darkness. Their lights cut through the black like search beams, revealing coral forests, vent fields, or drifting jellies. And because they can stay down for hours or days, they give us a window into a world we could never see on our own. They are our eyes in the abyss. Every deep dive reveals something new and unexpected. One of the most exciting truths about deep ocean exploration is also the simplest: we always find something new. Every dive, whether by submersible or zero-V or autonomous drone, brings unexpected discoveries. Sometimes it's a strange new fish with fins like wings or jaws like traps. Sometimes it's a colony of deep sea coral in a place no one thought they could grow. Sometimes it's a sound we can't explain, a chemical anomaly, or an ecosystem built around a volcanic vent we didn't know existed. Even after decades of exploration, the deep ocean continues to surprise us. In fact, scientists estimate that over 90 of deep-sea species remain undiscovered. Every descent is a kind of first contact, not with aliens from space, but with life from our own planet in the dark. Discovery is not rare, it's the rule. Many creatures found in the deep are still unnamed. In the deep ocean, discovery often comes faster than classification. Many of the animals captured on camera by deep-sea drones or collected during expeditions don't match anything we've seen before. Some resemble known species, but differ in shape, color, or size. Others are so strange that scientists don't even know where to place them. It can take years, even decades, to study a single specimen, compare its genes, and give it a formal name. In the meantime, researchers give them nicknames: Dumbo, octopus, psychedelic, jelly, gummy, squirrel. These placeholders remind us that we're still early in our understanding. The deep sea is full of creatures that science hasn't yet described, animals that live and die without ever appearing in a textbook or database. For now, they drift unnamed, glowing and feeding in silence, but their stories are waiting to be told. The deep sea is Earth's final living frontier. We've explored mountaintops, deserts, and even the surface of the moon, but the deep sea remains Earth's least known round. It stretches across more than half the planet's surface, yet most of it has never been seen. Not because it's unreachable, but because it's vast, dark, and difficult. It's a place where pressure crushes, light fades, and time slows. But it's also alive, pulsing with creatures that glow, drift, or burrow, many of which are still undiscovered. In this landscape of trenches, fence, and plains, life is adapted in ways we're only beginning to understand. The deep sea is not barren. It's brimming with secrets, some ancient, some utterly new. It is a frontier not of conquest, but of curiosity, a reminder that even here on our own blue planet, wild unknowns still remain. Mapping the ocean floor is one of science's greatest challenges. The surface of Earth's oceans covers more than 300 million square kilometers, yet less than 1/4 of the seafloor has been mapped in high resolution. Why? Because mapping the deep is hard. Satellites can't see through water, and sonar takes time to create detailed maps. Ships must crisscross the ocean, slowly bouncing sound waves off the bottom and measuring the echoes. It's like painting a portrait with a flashlight in the dark, one brush stroke at a time. The deeper the water, the harder it becomes. Trenches, ridges, and valleys can distort readings. Equipment must survive harsh conditions, and it's all incredibly expensive. But progress is happening. Projects like Seabed 2030 aim to chart the entire ocean floor within this decade. With every new map, the deep becomes a little less hidden, and the mysteries a little closer to home. Satellites help reveal the hidden landscape of the deep. Even though satellites can't see the sea fill directly, they can help us infer its shape. By measuring tiny variations in the ocean's surface height, caused by underwater mountains and trenches, tugging on Earth's gravity field, scientists can build low-resolution maps of the ocean bottom. For example, a seamount creates a slight bulge in the sea surface above it, just a few centimeters high. By stitching together satellite data over time, researchers can detect ridges, valleys, and other features no one has seen. These maps lack detail, but they're an essential first step guiding sonar surveys, ship expeditions, and robotic dives. In this way, space helps us understand the deep. Satellites orbit hundreds of kilometers above the planet, yet they whisper clues about places 11 kilometers below the waves. Sometimes the tools that look out into space also help us look back into Earth's own depths. Some features were found entirely by accident. Not all discoveries in the deep are made by design. In fact, many of the most remarkable underwater features, including coral reefs, seamounts, and hydrothermal vents, have been found completely by accident. A sonar signal might return an unexpected echo. A deep diving robot might catch a glimpse of a strange shape or a passing research vessel might notice an anomaly on its instruments and decide to investigate. One of the world's largest deep-sea reefs was discovered simply because a team took a detour. These surprises are a reminder of how little we truly know in the deep. There are no signs or landmarks. Most of the seafloor remains uncharted, so even the most routine expedition might stumble upon something no one has ever seen. The ocean is full of quiet astonishments, waiting not for permission, but for curiosity. And the water volcanoes lie hidden beneath miles of water. Beneath the ocean's surface, volcanoes are everywhere. In fact, the majority of Earth's volcanic activity happens underwater along the mid-ocean ridges, where tectonic plates pull apart. Magma rises from deep within the planet, building up new seafloor. These underwater eruptions form massive volcanic chains and seamounts, some of which grow tall enough to become islands, but most remain hidden beneath kilometers of water. The heat fuels hydrothermal vents. The shape influences ocean currents, and their eruptions can reshape entire landscapes without ever breaking the surface. Some undersea volcanoes are active, others dormant, and many more have yet to be discovered. Because of the difficulty in observing them directly, we often only detect eruptions after the fact through seismic readings, discolorations in the water, or sudden blooms of microbial life. Earth is still forming itself beneath the sea, one quiet eruption at a time. Some can erupt without a single splash. Not all volcanic eruptions are dramatic. In the deep ocean, an eruption can happen in total silence, with no explosions or fire, just magma flowing from fissures onto the seafloor. The immense water pressure suppresses steam and gas, muffling the blast. Instead of fountains of lava, these eruptions produce slow creeping flows that cool rapidly into pillow-shaped rocks. Sometimes these events go completely unnoticed until a submersible stumbles upon the fresh formations still warm and steaming. In other cases, sensors detect slight temperature changes or seismic tremors, hinting that something has occurred deep below. These quiet eruptions are incredibly common and essential. They build new crust-fuel hydrothermal vent systems and provide heat and chemicals that support life in the abyss. In the deep, fire doesn't rage, it seeps, and in the darkness Earth remakes itself without ever disturbing the surface above. Others slowly build giant domes of lava in the abyss. Not all volcanoes explode with fire. Some deep beneath the sea ooze lava so slowly that it forms enormous underwater domes. Smooth bulbous mounds called lava pillows or submarine lava domes. These structures are built layer by layer, as molten rock flows from deep fissures in the seafloor, spreads out and quickly cools into rounded shapes under intense water pressure. Some domes span kilometers in diameter and rise hundreds of meters off the ocean floor, taller than skyscrapers but invisible from above. Because they erupt slowly and silently, they can take decades to build, and they often go undetected until mapped by sonar or spotted by a passing submersible. These lava domes are the quiet architects of the ocean floor, slowly reshaping Earth's surface beneath miles of dark water. They remind us that creation doesn't always arrive with noise. Sometimes it rises in stillness. The sea floor is recycled by the Earth itself. Unlike the continents which persist for billions of years, the ocean floor is constantly being created, destroyed, and recycled. At mid-ocean ridges, new crust is formed as magma rises and cools. At subduction zones, deep trenches where one tectonic plate slides beneath another, the crust is slowly pulled back into the Earth's mantle, where it melts and begins the cycle again. The entire seafloor is on a kind of conveyor belt, moving outward from ridges and downward trenches. No part of the ocean bottom is permanent. In fact, the oldest known seafloor is only about 200 million years old, ancient by human standards, but young compared to continental rocks. The Earth continuously reshapes itself beneath the sea, breaking and remaking the planet's crust without pause. It's a process that spans lifetimes, continents, and oceans, quietly turning rock into fire and fire into rock again. Ocean plates move and shift like slow-motion tectonic gears. Earth's outer shell is divided into large slabs of rock called tectonic plates, and many of them lie beneath the ocean. These oceanic plates move constantly, though so slowly that we usually don't notice. They slide past one another, collide, or pull apart at speeds of just a few centimeters per year, about as fast as your fingernails grow. But over millions of years, this slow drift reshapes continents, forms islands, creates deep trenches, and builds underwater mountains. When two ocean plates meet, one may be forced beneath the other, triggering earthquakes or volcanic eruptions. When they spread apart, new crust is born. The deep ocean is one of the most active zones of plate movement, a hidden engine that drives much of Earth's surface activity. We walk on solid ground, but beneath us the planet moves in slow, grinding rhythms. The Atlantic Ocean grows wider by inches every year. The Mid-Atlantic Ridge is a vast underwater mountain range that runs like a seam down the center of the Atlantic Ocean. Along this ridge, two tectonic plates, the North American and Eurasian plates, are slowly pulling apart. As they separate, magma rises from below, creating new seafloor. The result? The Atlantic Ocean is growing, widening by about 2.5 centimeters per year. It's a pace so slow you'd never notice in a lifetime. Yet over millions of years, it adds up to oceans being born, continents drifting, and coastlines changing shape. If this process continues, the Atlantic could eventually become wider than the Pacific Plate. Tectonics isn't just something that happens during earthquakes. It's a constant, invisible force, reshaping our world from the bottom up. The ocean, it turns out, is expanding one quiet inch at a time. Some of the deepest earthquakes happen far beneath the sea. Most people think of earthquakes as shallow surface events, but some of the most powerful and mysterious quakes occur deep beneath the ocean, where tectonic plates grind, bend, and break under extreme pressure. These deep focus earthquakes can originate hundreds of kilometers below the surface, often in subduction zones where one plate is being forced beneath another. In some cases, these quakes are so deep and distant that they go unnoticed by anyone on land. Others send tremors that rattle entire coastlines. Scientists still don't fully understand how rocks can crack under such pressure. The conditions are extreme and the physics complex, but one thing is clear. Beneath the calm surface of the ocean, the planet is restless. The deep doesn't just host strange creatures, it holds tectonic forces as powerful as anything on land, forces that shape the world in silence. Undersea landslides can trigger devastating tsunamis when massive amounts of sediment suddenly collapse from a continental slope or seamount. The result is an underwater landslide, one that can displace enormous volumes of water and trigger tsunamis. These undersea avalanches are known as submarine landslides, and they can occur after earthquakes, volcanic eruptions, or even as a result of gradual buildup and failure over time. One of the most famous examples, the Storegga slide, occurred off the coast of Norway about 8,000 years ago and sent tsunami waves crashing into nearby lands. These events are rare, but when they happen, they can be catastrophic and difficult to predict. Some landslides involve more material than all the rivers of the world carry in a year. The deep may seem still, but beneath the seafloor sediments wait under tension, poised to shift, and when they do, the ocean moves with terrifying force. These landslides move more material than any river. When an underwater landslide occurs, it doesn't just stir up sediment, it can move billions of tons of material in a single event. Some submarine landslides are larger than anything we see on land, displacing more volume than all the rivers on Earth combined might carry in a year. The scale is staggering. One massive collapse can sweep mud, sand, and rock across hundreds of kilometers of ocean floor. These slides reshape underwater landscapes, destroy communication cables, and sometimes trigger tsunamis that reach distant shores. Because they happen deep below the surface, they're often invisible until their effects have felt or discovered years later through sediment cores and bathymetric scans. It's easy to think of the ocean floor as still and settled, but it isn't even in darkness. Gravity pools, pressure builds, and mountains fall. The deep is always in motion, sometimes suddenly, sometimes forever. Vast underwater canyons slice through the continental shelf just offshore from many continents. Hidden beneath the waves lie submarine canyons, massive valleys carved into the seafloor, often stretching from the edge of the continental shelf down into the abyssal plains. These canyons can be hundreds of kilometers long and several kilometers deep, rivaling the largest canyons on land. They shaped by ancient rivers, landslides, and powerful underwater currents that continue to sculpt them even today. Some are steep and narrow, others are wide and winding. Their walls may host coral sponges or filter feeders clinging to the slopes, and their channels act like superhighways for sediment, nutrients, and even marine life. Though hidden from view, these canyons are vital parts of the ocean's circulatory system, pathways that connect the shallow coastlines to the deep sea. To dive into one is to explore a world of silence, depth, and shadow, carved not by time alone, but by flow. One canyon under the sea is bigger than the Grand Canyon. Most people know the Grand Canyon as one of the largest natural wonders on land, but beneath the ocean is a canyon that's even longer and deeper, the Gem Chuck Canyon. Located in the Bering Sea, this massive underwater gorge plunges more than 2.2 kilometers deep and stretches wider than the Grand Canyon at its widest point. It was carved not by wind or rain, but by powerful currents and gravity-driven flows that have eroded the seafloor over millions of years. Like its terrestrial cousin, Jemtchug has steep walls, winding channels, and a complex structure of ridges and slopes. But unlike the Grand Canyon, it lies in complete darkness, barely mapped and rarely visited. The size and scale of such hidden features remind us how much of Earth's grandeur remains unseen, not because it's far away, but because it's underwater. These submarine valleys funnel sediment to the abyss. Submarine canyons aren't just dramatic, they're dynamic. These deep valleys play a key role in transporting sediment from land to the deep ocean. Storm runoff, river discharge, and coastal erosion all contribute material to the continental shelf, but it's the canyons that funnel it down into the abyss. As the sediment flows, it forms turbidity currents, dense, fast-moving underwater avalanches that can travel for hundreds of kilometers along the canyon floors. These currents carve, deposit, and reshape the seafloor as they go, creating layered sediments in the deep ocean basins. Over time, this process builds up thick blankets of silt and clay that bury the ocean floor and preserve a record of Earth's past. In this way, submarine canyons act like geological arteries, carrying not just earth and stone, but the story of everything that is washed down from the land above. The ocean floor stores the history of Earth's climate layer by layer, year by year. Ocean floor collects a record of the world. Tiny particles of dust, volcanic ash pollen, and microscopic shells settle to the bottom, slowly forming sediment layers that can be thousands of meters thick. These sediments trap chemical signatures and biological clues that reflect the Earth's past. The temperature of the oceans, the levels of carbon dioxide, the movement of continents, and even the timing of Marseid extinctions. By drilling cores into the seafloor and analyzing the contents, scientists can read this record like pages in a book. Some cores stretch back tens of millions of years, revealing ice ages, warm periods, asteroid impacts, and ancient ecosystems long vanished in the deep. The past never disappears. It settles softly, accumulates silently, and waits undisturbed until we come looking for the story it has to tell. Ancient sediment cores hold secrets from millions of years ago. A single sediment core from the deep ocean might look like nothing more than a column of mud, but hidden within are clues to Earth's most dramatic changes. Each layer is a timestamp recording a season, a storm, or an extinction. Coals have revealed traces of the asteroid that ended the age of the dinosaurs. Layers have soaked from ancient wildfires and shifts in ocean chemistry that signal climate change events. Microscopic fossils, called foraminifera, can be studied to reconstruct past ocean temperatures, while isotopes tell us about ice coverage and atmospheric gases. Some cores stretch back 65 million years or more of frozen history of a living planet. Extracting them requires precision, patience, and deep-sea drilling vessels that can operate under harsh conditions. But what we gain is priceless. A long, silent story of Earth, buried beneath kilometers of water and written in dust. Microscopic fossils revealed past worlds now lost to time. Hidden in deep-sea sediment cores are the remains of tiny creatures that once floated near the ocean surface. Microscopic fossils that hold vast stories. These include foraminifera, tiny shelled organisms, lived for short periods, but left behind countless preserved remains. Each species thrived under specific environmental conditions, so by identifying which foraminifera are found in which layer, scientists can reconstruct ocean temperature, salinity, carbon levels, and climate trends going back tens of millions of years. Some of these layers correspond to global events: the rise of mammals, the retreat of glaciers, the abrupt warming of ancient oceans. What's remarkable is that these fossils are so small, most can't be seen without a microscope. Yet they provide one of the most detailed records of Earth's ancient climate systems. They are Earth's diary written in shells, no wider than a grain of sand. Mining the deep could damage fragile ecosystems forever. In recent years, companies and governments have shown growing interest in deep-sea mining, the extraction of minerals and metals from the ocean floor. But with this interest comes serious concern. Much of the deep ocean is fragile and slow to recover, with creatures that grow slowly, reproduce rarely, and depend on specific environmental conditions. Disrupting these ecosystems even slightly could cause long-term damage that lasts centuries or longer. Mining machines would stir up thick plumes of sediment, smothering nearby life and possibly spreading for miles. Entire coral communities or microbial colonies could be destroyed before they're even studied. The deep sea isn't just remote, it's vulnerable. And unlike the surface, it can't heal quickly. Scientists and conservationists warn that if we open the deep to industrial mining without full understanding, we may lose one of the most mysterious and valuable parts of the planet forever. Metal nodules litter the sea floor like alien pebbles scattered across vast stretches of the deep ocean floor. Strange round formations called polymetallic nodules. These rocky lumps look like smooth pebbles or black potatoes, but they're composed of valuable metals like manganese, cobalt, nickel, and copper. Unlike traditional laws, they don't need to be mined from rock. They sit loose on the seabed waiting to be collected. But these nodules take millions of years to form, growing just a few millimeters per century. They often host unique ecosystems, tiny organisms clinging to their surfaces or hiding in the sediment around them. To harvest them, machines would need to scrape or vacuum the seafloor, a process that could destroy habitats we've barely begun to understand. These nodules offer a glimpse of planetary time and mineral formation untouched by human hands. They're not just resources, they're geological relics of the deep. These metals are used in phones, batteries, and satellites. The same metals found in deep-sea nodules, like cobalt, nickel, and rare earth elements, are essential to modern life. They're used in smartphones, electric vehicle batteries, renewable energy systems, and spacecraft electronics. As global demand for these materials increases, especially for clean energy, technologies companies are searching for new sources, and the deep ocean has come into focus. Unlike land mining, which requires digging and refining, these nodules could theoretically be gathered from the seafloor with less overburden. But the trade-off is high: the potential loss of fragile, untouched ecosystems and species unknown to science. The metals may power green technologies, but their extraction could leave a scar on one of Earth's oldest, quietest realms. It's a dilemma that highlights the complexity of sustainability. How do we build a better future without destroying what we've never truly seen? We're debating whether to leave them undisturbed. As interest in deep-sea mining grows, so does the debate about whether it should happen at all. Scientists, policymakers, and conservation groups are asking, should we extract resources from a world we barely understand? Some argue that the metals are essential for a transition to clean energy. Others warn that the cost to ecosystems, biodiversity, and unknown species may be far too high. International bodies, like the International Seabed Authority, are working to develop guidelines, but many experts say we need more time, more data, and more caution. The deep ocean is slow to change and slow to heal. Damage done there could last for centuries. For now, the nodules sit in silence, scattered like seeds across the seabed, and the question remains unanswered: will we take them, or will we leave them untouched? A treasure that remains hidden, not because it's forgotten, but because it's protected. Climate change is reaching even the ocean's darkest corners. We often think of the deep sea as untouched, a realm beyond human influence. But even here, climate change is leaving its mark. Warming surface waters affect ocean currents, which in turn alter the movement of heat, oxygen, and nutrients into the depths. Some deep zones are becoming less oxygenated, threatening species adapted to stable, low-oxygen environments. Others are experiencing subtle changes in acidity, temperature, or carbon balance. These shifts may seem small, but in ecosystems that evolved slowly over millennia, even a slight change can be profound. Species may migrate, disappear, or lose the delicate balance they depend on. Coral reefs in the deep are also vulnerable to warming and acidification, just like their shallow water cousins. The deep sea is out of sight, but it is not out of reach. Human impact travels far, and even the abyss is beginning to feel the change. Ocean currents carry heat, salt, and life around the world beneath the surface. Vast rivers of water move silently through the sea, not just across it, but through it from top to bottom. These thermohaline currents are driven by differences in temperature and salinity, and they form part of what's called the global conveyor belt. As cold, salty water sinks near the poles, it flows deep across the ocean basins, carrying nutrients, carbon, and energy along with it. These deep currents help regulate Earth's climate, distribute marine life, and sustain ecosystems thousands of kilometers away. They can take hundreds of years to complete a single loop. If disrupted by warming or changes in salinity, entire weather patterns could shift. The ocean doesn't just respond to the climate, it helps shape it. And in the deep, the quiet flow of water is one of the most powerful forces on the planet. Deep ocean absorbs massive amounts of carbon. The ocean is one of Earth's greatest carbon sinks, and much of that carbon ends up in the deep sea through a process called the biological pump. Phytoplankton near the surface absorb carbon dioxide during photosynthesis. When these microscopic organisms die, or when they're eaten and excreted, their carbon-rich remains slowly sink through the water column. Over time, this material is buried in seafloor sediments, locking away carbon for centuries, or even millennia. The deep sea plays a crucial role in regulating the planet's carbon balance, slowing the pace of atmospheric change. But if warming waters alter ocean circulation or reduce oxygen levels, this delicate balance could shift. The abyss may seem passive, but it is actively working, absorbing, recycling, and storing the byproducts of life above. Its silence hides a crucial function, helping Earth breathe, but its balance may be more fragile than we thought. For a long time, scientists believed the deep ocean was too vast, too cold, and too isolated to be easily affected. But now we know that even small disturbances can ripple through its systems. Changes in temperature or oxygen levels can alter migration patterns, feeding behaviors, and reproductive cycles. Coral reefs that took thousands of years to form may weaken in just decades. Sediment layers show signs of shifts tied to surface changes, clues that the deep responds faster than we once imagined. Because life here moves slowly, it also recovers slowly. A single disturbance could take centuries to heal. The deep ocean may be fast, but it is not invulnerable. It is interconnected, reactive, and surprisingly delicate. And the more we study it, the more we see that protecting it isn't just about saving the deep, it's about safeguarding the planet. Plastic has been found in the most remote trenches. In 2018, researchers exploring the Mariana Trench, the deepest known place on Earth, found something unexpected: a plastic bag. Later, microplastics were detected in sediments in animals, and even in the stomachs of amphipods from depths exceeding 10 depth 0 meters. These particles, smaller than a grain of sand, likely drifted down from the surface, carried by currents, or attached to sinking organic matter. Once there, they can persist for hundreds of years, entering food webs and potentially altering fragile ecosystems. The discovery was sobering. It showed that no part of the planet is untouched, not even the deepest, darkest trenches. Pollution travels downward quietly and visibly. The deep sea is vast, but it is not immune. Even here, in the most remote and ancient of places, the footprint of human activity reaches all the way to the bottom. Even deep sea creatures contain tiny bits of plastic. Recent studies have found microplastic particles inside the bodies of animals living thousands of meters below the surface. These include amphipods, worms, and even some species of deep sea fish creatures that have never been near the light, left alone the surface. The plastics come from above, breaking down from bags, fibers, or packaging into microscopic pieces that drift through the water or settle on the seafloor. Deep sea organisms feeding on marine snow or sediment ingest these particles unknowingly. The long-term effects are still unknown, but scientists worry that plastics may affect reproduction, growth, or digestion in ways we don't yet understand. In a realm shaped by slowness, stability, and balance, even the smallest contaminant can be disruptive. These findings remind us that pollution is not just a surface problem. It sinks and it stays. Some nations are creating deep ocean reserves for protection in response to growing concerns about exploitation. Several countries and international bodies are working to establish marine protected areas that include parts of the deep sea. These reserves are designed to safeguard unique habitats such as hydrothermal vents, cold water coral reefs, and seamount ecosystems from fishing, mining, and drilling. Protecting these areas isn't easy. Enforcement is challenging, and much of the deep ocean lies outside national borders, but the idea is spreading. Some nations have declared large swaths of their ocean territory off limits to extractive activity, preserving biodiversity and allowing ecosystems to remain untouched. These protected zones offer scientists a chance to study nature as it has existed for millennia, slowly, silently, in its own time. And the vast darkness reserves may be our best hope of ensuring that some parts of the deep remain wild, quiet, and whole. Life in the deep is stranger than we ever imagined. Every dive into the deep sea reveals something new, and often something utterly bizarre. There are creatures with transparent bodies, fish that walk on fins, Worms that resemble feathers and jellies that light up like fireworks. Some animals live without mouths or stomachs. Others glow, vanish, or unfurl like paper lanterns. Evolution in the deep follows different rules shaped by darkness, pressure, and isolation. What would be impossible on land becomes commonplace here. The deep isn't just a darker version of the surface. It's a different world altogether, one where life is flexible, strange, and endlessly creative. For every mystery we solve, another arises. For every known species, there may be dozens we've yet to discover. The deep doesn't imitate the surface, it reinvents it. The deep sea begins where sunlight fades to black. Scientists divide the ocean into zones. The deep sea begins just past the edge of light. This boundary is called the mesopelagic zone, or more poetically, the twilight zone. It begins around 200 meters down and stretches to 1,000 meters where the last hints of daylight vanish. Below that lies the bathypelagic zone, a place of complete and permanent darkness. No sunlight reaches this depth. Temperatures drop, pressure rises, and life begins to look profoundly different. In these zones, photosynthesis becomes impossible, and most food arrives as a slow drift of falling particles from above. It's a world without seasons, without sky, and without storms. A world where creatures glow, shimmer, or become nearly invisible. It's also not a rare environment. It makes up the vast majority of our planet's living space. The deep sea is not a distant outpost. It's Earth's hidden heart. Its ecosystems could help us understand life on other worlds. Hydrothermal vents, methane, seeps, chemosynthetic life. These deep sea systems don't depend on sunlight, and that's exactly why they fascinate astrobiologists. If life can thrive around superheated vents in total darkness, it might also survive in the subsurface oceans of Europa, Enceladus, or even Mars. The deep ocean is our best analog for alien environments. Studying its microbes and creatures may help us recognize signs of life elsewhere. What kinds of chemistry can support biology? What adaptations allow survival without light? These questions don't just matter to oceanographers. They matter to anyone wondering whether we're alone. The deep is our laboratory for the unknown, and in its strange, quiet corners, we glimpse what life might look like beyond Earth. The deep ocean holds mysteries we haven't even dreamed yet. For all our technology and exploration, the deep ocean remains profoundly mysterious. Over 80 of it remains unmapped, unseen, and unexplored. We don't know what species are out there, how ecosystems are connected, or how many geological wonders lie undiscovered. Every expedition returns with questions we didn't know to ask. The deep resists simplification. It doesn't offer easy answers. Instead, it invites all the kind that comes with recognizing how little we truly know. We peer into its darkness with curiosity, wonder, and humility, and in return, it offers glimpses of the astonishing. There is no end to its surprises. The deep ocean is not just a place. It's a reminder that the world is still wild, still vast, and still waiting to be discovered. Even in darkness, the deep ocean shines with wonder. No light from the sun ever reaches the deep, yet it glows with bioluminescent creatures, with heat from vents, with a shimmer of strange bodies, drifting through silence. But more than that, it glows with meaning. It reminds us that life adapts, assists, and even flourishes in places that seem impossible. That mystery still exists, that beauty can be found where no one is watching. The deep ocean is full of strange truths, slow rhythms, and living things that defy expectation. And though we may never walk its floor or hear its voices firsthand, we carry its story with us in what we protect, in what we wonder, and in the questions we ask. Even in darkness, the deep ocean shines. So now let your mind settle like silt on the ocean floor. We've wandered through canyons carved in silence, through forests of coral that never saw the sun. We've watched robots hover like curious lanternfish, and seen humans descend to depths when no light has ever fallen. We've drifted beside creatures that shimmer, flicker, vanish, who've never known warmth or sky or shore. We've listened to the ocean's heartbeat, slow-moving plates, whispering currents, ancient fossils, falling through darkness like snow. We've seen life form without sunlight, thrive without surface, exist in shapes we never imagined. The deep ocean is not empty. It's not still, it breathes. It shifts, it glows. It remembers. It reminds us how much wonder still hides in this world. Not in the stars above, but in the darkness below. Not beyond Earth, but within it, quiet, vast, and full of secrets. So let those thoughts drift gently. Now let the silence widen, let the weight of the chauri see fold around you like a current, soft and slow. Sleep like the ocean takes you inward, sleep like the ocean holds you. And if you happen to still be awake, you can go ahead and watch the next video. Otherwise, close your eyes and let the deep carry you the rest of the way. Good night, I never thought.